Hi, I'm Brian Sloboda. Today, CRN is on the road in Selmer, Tennessee at the headquarters of Pickwick Electric Cooperative. The folks here at Pickwick are testing an amazing and innovative new system that can predict when and where an outage will occur days, sometimes weeks, before they actually happen. Come with me as we go inside to learn more. Outages are caused by many factors. Equipment failure, extreme weather, and accidents are some of the leading causes. They generally occur with little or no warning. John Bowers is the Vice President of Operations at Pickwick Electric Cooperative, a 20,000 meter system located here in Tennessee. John and his staff have been testing a new system called the Distribution Fault Anticipator. The DFA is a system that has the potential to radically change how utilities perform preventative maintenance and prevent outages. What is the Distribution Fault Anticipator and how are you using it?
The DFA is a device that we've installed in our substations using bus CTs and PTs to capture currents and voltages and generate capture files when things happen on our system that we want to know about. And the DFA automatically recognizes normal system events and separates them from the other events, the faults, the switch capacitors. Sometimes you may have a fault that happens only once every week or two, once every few days. These things a lot of times go unnoticed. The DFA allows us to know that that's happening. We have an example of that on the screen right here. The DFA has identified 5 events, and the DFA is telling us that this is a possible recurrent fault. The first 2 events occurred on May the 25th, and this actually occurred when we were having some thunderstorms, so these 2 in themselves weren't that troubling. But we continued after the fact to have 3 more events, one on June the 2nd, one on June the 4th, and one on June the 13th. And this is something that we want to know about because this is a fault that perhaps we can go out there and find and maybe prevent an outage.
Now, if you did not have the DFA, would you know that this is happening?
Most likely we would not unless a customer called, and we haven't had any calls on this particular event. This is a downline single-phase recloser that's operating. You don't have any communication with it. It's a hydraulically controlled device. So we most likely would not know it if we didn't have these capture files from the DFA.
So if left unchecked, what will happen? Will there be an outage?
We have seen time and time again that these things usually do produce an outage. So we can take these pieces of information and many times we can really narrow down the area where we need to look to find the fault.
So the system are making your field crews pretty happy then?
Yes, we've saved a significant amount of time searching for trouble faults.
And your members are having decreased outage time as well?
Decreased outage time, decreased blinks. A blink like this, not only the people on this particular feeder see it, but everyone served from that substation transformer on C phases is going to see that blink. The DFA also gives us the waveforms. Here are the RMS currents. We can see the fault, almost 500 amps of current there. C phase in the green and the neutral in the brown, so this is a C phase to ground fault. We see the breaker trip and the fault go away, and then we see the reclose inrush and the load is successfully restored.
Now, how long does it take from the time that the fault actually occurs until it appears on this website?
It's usually just a few minutes. To give you an exact time would be hard to say, but within 4 to 5 minutes it'll be there.
So this is a real near-time view of what's going on your feeders?
Yes.
Have you ever had that capability before?
No, we have not.
Could you imagine going forward without the DFA?
I think it would be a real shame if we had to move forward without it. I think this is too important. We need to continue working with this and advancing this technology.
If one vendor used the DFA system and another vendor didn't, would you be more inclined to go with the vendor?
Absolutely, absolutely. And I think that will be the case with a lot of systems, especially rural systems like ours.
What sort of hardware and software makes up the DFA system?
The DFA, the box itself is deployed on one feeder. That's the way we're deployed anyway, is one box per feeder. We're monitoring bus PTs and CTs, currents and voltages, and the DFA captures the waveforms, and then inside the box itself it sorts through them, decides what each event is, and it picks the ones that it determines that we want to know about and sends them to us and displays them on the website.
The Distribution Fault Anticipator is not a commercial product. You can't go out and buy it from your traditional vendors. Who are you working with to demonstrate this software, and who developed it?
This is a project with the Electric Power Research Institute, Texas A&M University, and TVA. We are a TVA distributor, and TVA needed a distribution system on which to demonstrate the DFA, and we were lucky enough to be selected as that system.
A lot of times systems developed by universities aren't that practical. They tend to be a little out there, a little academic. How's DFA working for you now?
It's been very practical. The recurrent fault is just one of the things that we've been able to utilize the DFA for. Other things include monitoring capacitor banks. You can see your capacitor bank switch. You can tell if you have failed packs inside a capacitor. You can tell if the switches are operating correctly, not bouncing, not arcing, and the timing of the switch, you can see that. You can also look at your sectionalizing schemes and determine if they're operating correctly. You can check for miscoordinations to find out what went wrong. Many things, many uses that we've found for the DFA.
What's the next step for DFA? You've been working closely with TVA and Texas A&M. What else needs to be developed before DFA becomes a commercial product?
Hopefully, at some point in time, some big company will take the software and take the package, and we'll have a commercial version. But even at its current state, it's still very useful. Commercialization is what we hope to happen.
How many additional demonstration sites do you think something like the DFA needs to really get going to that commercial level?
The more the better. I think it's a matter of manufacturers realizing that the technology is out there and that systems or engineers would want this deployed on their system. That's the key hurdle right now. We have to show or demonstrate that people want this technology.
Going forward, how important do you think something like the DFA could be to co-ops?
The DFA gives you the ability to prevent outages. We've demonstrated that time and time again. The DFA gives us the ability to do maintenance on our capacitor banks in a just-in-time fashion. We've been able to see that very easily. It also gives us a lot of information about our sectionalizing schemes and the performance of our reclosers and all of the devices on the system. The DFA is about situational awareness, and that is big, and we feel like that's something that people will want.
Is there any idea of how much money the DFA has saved you, or how much outages have been diminished because you've been using DFA?
Haven't really tried to put a dollar figure to it. That's something we probably should be doing at this point in time, but we've been able to demonstrate over and over again that we can prevent outages.
DFA sounds like a truly innovative product. Thank you so much for letting us come by today, John.
Thanks, Brian.
The typical distribution co-op has mile after mile of line. Take a look at that map. It takes field crews a long time to go out there and drive those lines looking for faults. Now, the Distribution Fault Anticipator helps to narrow down the exact location where faults are occurring. But more importantly, it's finding faults that the co-op didn't previously know they were having. Pickwick Electric Cooperative has been the perfect test site for the Distribution Fault Anticipator. Now, the product isn't fully developed and it's not fully commercialized. It needs additional fine-tuning. CRN is looking forward to partnering with Pickwick Electric, TVA, and Texas A&M to further refine and develop the Distribution Fault Anticipator. So stay tuned over the coming months as we talk more about the DFA system. In the meantime, if you want to learn about other exciting and innovative co-op programs, visit the CRN Center for Energy Innovation on cooperative.com.